review how to solve quadratics by factoring. The most important thing about factoring is we cannot factor unless our equation is set equal to 0. So you'll notice in that first step, we have our equation equals -8. So we add 8 to that side. So our quadratic is set equal to 0. The next most important thing is checking for a greatest common factor, a GCF. A GCF is a number that can go into each of these terms. So when we break down 4x squared, 16x, and 12, we should notice that 4 goes into each of them. So I'm going to divide out a 4 from each term. 4 divided by 4 is 1. 16 divided by 4 is 4. 12 divided by 4 is 3. So what's left? What's going on here? Well, this is what we have left to factor, this x squared plus 4x plus 3. So we want to be able to identify the a, the b, and the c value. Remember, when we talk about quadratics, we factor from standard form here. Okay, the GCF no longer matters. Remember, we created an x to organize our thoughts. On the top of our x, we had a times c, so 1 times 3 is 3. And at the bottom of our x, we had a b value, 4. Remember, to complete our x, we want to know what multiplies to be the top but adds it to be the bottom. So what multiplies to be 3 but adds up to be 4? Well, there's only one factor of 3. You can change the signs all you want, but there's only one factor, and we want them to both be positive because 1 plus 3 equals 4. Okay. Then remember, we moved into a step called grouping. Okay, we grouped our quadratics together. So we have to rewrite our term, our linear term. So if we go back up here, notice here we have 4x. That's our linear term. We've replaced that 4x with 1x plus 3x. Okay, 1x plus 3x. We factor by grouping the first two terms and the second two terms. So looking at these first two terms here, we want to know what their greatest common factor is. There's not a number, but the variables still count. So they both have an x, that's the GCF. And remember, we have to write the remaining factor. X times x is x squared. X times 1 is 1x. We have to do the same thing for the second half that we grouped together. What do 3x and 3 have in common? They have a 3. So that's our GCF. And we can't forget about the remaining factor. We know 3 times x is 3x. 3 times 1 is 3. So what do we do with this piece of information now? When we write factors, it's two binomials multiplied together. So we need to find those two binomials. One of them is made up of the GCFs, so x plus 3. The other one, if you'll notice, your factors repeated. That's a reminder that we did factoring by grouping correctly. So we have these that repeat. That makes up this other factor here. Okay, so we factored, but remember, we're learning to solve, okay? To solve by factoring. So we're going to set each equation equal to 0, and we're going to solve each one for x. Okay? So since it's a positive 3, we subtract it. We get x equals -3. We have a positive 1, so we subtract it. We get x equals a -1. So let's work on two more examples together. You can pause the video to write down those examples, and I'm going to continue to share my screen here so we can go through these steps and work on these examples together. So I've rewritten them here. These are the two examples at the bottom of your notes page. So remember here, the first step is to set your equation equal to 0. So I'm going to add 3x to both sides. Okay. Now, when I add it, I'm actually going to put this 3x in the middle. When I rewrite it, I'm going to write 5x squared plus 3x minus 2 equals 0. Now, the reason that I wrote it that way is because remember the standard form of a quadratic is ax squared plus bx plus c. So we want our quadratic in standard form. That means we have to put that 3x, that linear term, in the middle there. Now that we have it equal to 0, okay, we want to look for a GCF. That's step number 2. But 5, 3, and 2 don't have anything in common. So I'm going to go to my next step here. I want to identify my A, my B, and my C term. I'm going to do so just by placing the letter, well, I kind of already done that. Notice that this is my A term, this is my B term, and this is my C term. Okay? So I'm going to create my X. On the top, remember that's A times C, so 5 times negative 2, it's negative 10. And on the bottom, that's my B value is 3. So what are we looking for? Okay, now we're up to step number 5 here. We want to know what multiplies to be 10, but could add up to be 3. So I know that's going to be 5 and 2, but what are my signs going to be? If I need a positive 3, I'm going to make this a negative 2. 5 times a negative 2 is a negative 10. 5 minus 2 is 3. So that brings me to step 6. I want to rewrite my quadratic equation. So I'm going to have 5x squared, let's say plus 5x minus 2x minus 2 equals 0. Okay. All right, so now we want to get into the grouping. Okay. So when we group, we're grouping the first 2 terms first. So out of these first 2 terms, what do they have in common? Both of them have a 5 in common and an x. So what's left over is x plus 1. If I were to multiply this out, I'm going to get these first 2 terms back. 5x squared plus 5x. But I can't forget about the next 2 terms. These 2 terms also get grouped together. So when they're grouped together here, this is a negative 2 they have in common. You always want to take the sign that's out front here. This is a negative 2, and what's left is x plus 1. Remember, when you take the sign, when you make it negative, all the signs on the inside are going to change. Again, if I were to multiply this all out, I'm going to get back to those 2 terms. So let's write this as a product of 2 binomials. So when I do that, remember your GCFs become one factor, 5x minus 2. The terms that repeated also become a factor, x plus 1. We're going to set each factor equal to 0 and solve. So this is going to be 5x minus 2. Looks like I didn't leave myself enough space here. That's equal to 0. And x plus 1, that's equal to 0. So I'm going to solve each one for x here. So this is going to be 5x equals 2. I'm going to add the 2 to both sides. And x is going to equal 2/5 because I can divide both sides by 5 there. Here, if I have a positive 1, I'm going to subtract the 1 from both sides, and there's my final answers. Okay, these are my solutions. However, what's another name for solutions? Both of these are solutions. What's another name? x-intercepts. What's another one? Zeros. What's another one? Roots. Remember, x-intercepts is often what we refer it to because when we think of quadratics, we want to think of their graph. Okay? So by solving, we found there are two x-intercepts. This is where this graph crosses the x-axis. Let's continue with example number 2. With example number 2, we should notice that there are only two terms. Okay? When there are only two terms, the first question we're going to ask ourselves, is there a GCF? So when there are two terms, there must be a GCF. Otherwise, it's going to be very difficult to solve. So the GCF here, what can go into 6 and 36? 6. What can go into x squared and x? X. But what's left over? 6x times what gives me 6x squared? X. 6x times what gives me a negative 36x? Negative 6. Now if you'll notice, you have two factors set up here, two things multiplied together. So I'm going to set each factor equal to 0. If I divide both sides here by 6, x equals 0, which is a number, that counts. And if I add 6 here to both sides, x equals 6 is my other factor. If you need more examples, tune into the other videos posted on the blog. Happy studying!